All right, so getting us started with part 2 of the Peardeck, I just want you to reflect on what are those differences that you've seen so far between and or. And you're going to be responding on this slide independently, thinking about how did those graphs look differently, and what were just the differences or similarities that you noticed between the and compound inequalities and the or ones. And when you're all set, push ahead to slide 12. So this is what a compound inequality can look like. We see there is the x variable is in the middle, and we want x to be alone. So we want in the middle to just be an x. That's our goal. So the first thing that we're going to do is we're going to get rid of this negative 10 by adding 10. But now we don't just have two sides, we actually have three sides that we have to add 10 to. We need to add it to the left, to the right, and in the middle. In the middle is where it will cancel. Negative 8 plus 10 is positive 2, is less than or equal to 1/2 x, which is less than 5. Then, to get rid of this 1/2, we're going to multiply everything by 2. In the middle, on the left, and on the right. 2 times 2 is 4, is less than or equal to. 2 times 1/2 cancels, and we're just left with x. And 5 times 2 gets us 10. So here's our compound inequality here, where x is greater than or equal to 4. So we're going to put a closed circle on 4. And then it's less than 10. So we're going to put an open circle on 10. And this is an and inequality. We're shading that area in between. So it has to be greater than or equal to 4 and less than 10. Beautiful. And when you're all set, you can push ahead to slide 13. That was just the first one that we did like this. We're going to do some more practice solving compound inequalities. Here's another one. So to get us started, there's a couple things we could do. We could certainly distribute that positive 3 first in the middle. So we would have negative 6 is less than 3 times x is 3x, and 3 times 1 is a positive 3, which is less than or equal to 9. So the first step, all we did there was distribute that positive 3. Now we're going to move this plus 3 here. So we have to subtract it from the middle, from the left, and from the right. Negative 6 minus 3 is a negative 9, which is less than 3x. 3 minus 3 cancels to 0. So less than or equal to 9 minus 3 is 6. Okay. Last step we're going to do here is we're getting rid of that 3. So we're dividing everything by 3. And our inequality reads negative 3 is less than x, which is less than or equal to 2. So we're going to put an open circle on negative 3 and a closed circle on 2. And we're filling out that space in between. So x is going to be bigger than negative 3, or it's going to be smaller or equal to a positive 2. These are all and inequalities. We can write them as one combined. We're always looking for that space in between. Slide 14, when you're ready. Here's an or inequality. When we have an or, they are always written separately. So we solve them separately. We have negative 4x is less than or equal to a positive 20. So we're going to divide both sides by a negative 4 to get x alone. And of course, because we're dividing by a negative, we have to flip that sign. So this becomes x is greater than or equal to 20 divided by negative 4 is a negative 5. And that's one of our graphs. We're going to put negative 5, and it's going to be a closed circle, and we're going all the way to the right. All the numbers greater than -5. And then on the other inequality, we're going to subtract 1 first. And then we get 3x. 1 minus 1 is 0. So we have 3x is less than 9. And then we're going to divide both sides by 3. It's a positive 3, so the sign stays the same. We just get x is less than 3. So x is less than 3. We have an open circle on 3, and it's all values that are less than that. So that's going to the left. So we have this big overlap area. Notice like the whole entire graph is actually covered. And what this means is that this solution is actually all real numbers or infinite solutions. So we got this OR statement. And with that OR statement, our whole graph ended up being covered. So that is infinite solutions. Any value of x would make this compound inequality true. Okay. Once you have that all set, push ahead to slide 15. Beautiful. It says solve and graph this compound inequality. X plus 1 is greater than 6. So we're just going to move that plus 1 by subtracting it on the left and on the right. And then we have x is greater than 5. Or on the right, we're going to subtract 5 from both sides. And then we get a negative 2x. 5 minus 5 cancels to 0, is less than or equal to negative 9 minus 5 is a negative 14. And then we're going to divide both sides by negative 2. And then we get x. Because we divided by a negative, we flip that sign. Negative 14 divided by negative 2 is a positive 7. So we're going to do an open circle on 5. So it has to be greater than 5, and we're going to shade it to the greater side. And also, or it can be greater than or equal to 7. So we put that closed circle on 7 and greater. So essentially, it can be greater than 5, and that would satisfy both of these inequalities here. Okay. About 4 or so more here. Push ahead to slide 16. And this asks us to write a compound inequality from the graph. Notice we have the arrows going in opposite directions. So this doesn't always happen with an OR, but when we see that, this is going to be an example of an OR. So on the left are x values. We see a closed circle on negative 8, and they're shaded to the left. So they're less than or equal to negative 8. Or we have an open circle on 0, and it's shaded to the right. So, or they can be greater than 0. And those are our two inequalities. Okay. And when you're ready, push to slide 17. For this one, we have this overlapped between area. So x can be greater than negative 9, right? We see an open circle on negative 9, and it's shaded to the right. And x is less than negative 2. So we're kind of nestled between negative 9 and negative 2, and x is going to be in the middle. X is greater than negative 9 and less than negative 2. So we put those two symbols in there, and since they're both open circles, we don't want to put the or equal to, we just leave them as is. Okay. And when you're ready, push ahead to slide 18. Another compound inequality here to write. We see two closed circles here. We see a closed circle on -3, and we see a closed circle on 2. On the left, the closed circle from -3 is shaded to the left where the numbers are getting smaller, so it's less than or equal to -3. And on the right, or x can be greater than or equal to that number 2. And so that's our two inequalities for this compound inequality. And push to slide 19 when you're ready. We'll do our last one here. So we see, we know we're going to have an x, we have a -2, and then another x and a 1. -2 is an open circle and it's shaded to the left, so that's going to be less than. So x is less than -2, or x can be greater than or equal to +1. Right, we see that solid circle on 1, and the numbers are getting bigger. We're shading to the right. So after these two videos of the Peardeck, I just want you to check in with yourself on slide 20 and move this star to show how confident you're feeling so far in this topic. Anywhere along this scale is exactly perfectly fine. We're going to be doing more practice together as a class, so just know that if you're not feeling super confident now, we'll be doing more practice as we continue on. If you need any support or any help working through this, always you can reach out to me, send me an email, and we can find a time to meet. Okay, my friends, take care, and I'll chat with you soon. Bye.